All right, this lesson is dealing with conditional probability. It's going to be our last lecture in our probability unit. Before we begin, go ahead and take a look at the warm-ups. We're not going to go over number 2, just so you know. Depending on how you look at it, you could get two different kinds of answers. It just depends how you read it, so there would have to be more clarification for it. So go ahead and skip that one and come back and watch the video to make sure that you're understanding what's going on. For number 1, it says that the probability of R is 34%, the probability of R intersect Q is 19%, the probability of R union Q is 75%. What is the probability of Q? Now, if you want, and for me personally, I would draw a Venn diagram of this and put these pieces where they belong in the Venn diagram. Remember, when you're putting the numbers in, 0.34 doesn't go in the moon shape of R. It goes under the line of R because it represents the total R. Same thing for Q there. The union would be the combination of all three inside pieces, and the intersection would be the football. And then you can figure out things from there. But if you use the addition rule that we talked about last time, remember the addition rule said the probability of the union equals the probability of the single event plus the probability of the other single event minus the probability of the intersection. So in this case, the probability of R union Q is equal to the probability of R plus the probability of Q minus the probability of R intersect Q. And this is a little bit backwards from how we used the addition rule the other day, but we can then just take these values and plug them in where they belong in the equation. Well, the union is 0.75, R is 0.34, and we don't know what the probability of Q is, but we do know the probability of the intersection, which is 0.19. From here, it's just an algebra equation. We'll combine like terms. So 0.34 minus 0.19 is 0.15, and then we'll subtract that, so we end up with the probability of Q is 60%, or 0.6. For number 3, we are doing, this is going way back in time. We're doing a transformation such that we're doing a dilation of a translation of this triangle, and we're looking for the coordinate of A at the end. So the coordinate of A now is -3, 1, and after we do, well, what do we do first? We do the translation first, so after we move it 4 units to the right and 2 units down, A prime would be 1, -1, and then after we do the dilation, remember to do the dilation, we're doing it by a scale factor of 3, so we're just going to take our coordinates and multiply by 3. So we end up with 3, -3 is our final answer. Let's go ahead and get started with our notes today. We're looking at conditional probability. Now, conditional probability is the only probability where the sample space is going to change. In all of the other cases that we've talked about before, the sample space is the entire group of people or the entire group of selections, if you would. And so conditional probability actually narrows down our focus to only consider certain parts of our group. So conditional probability, it is the probability that an event occurs given that another event occurs. Okay? So the example I can give you is, I guess the simplest example is this. If I were to ask our entire class, all right, there are 24 kids in our class, how many of you think that tacos are the best meal, right? We would get a certain amount of students that would raise their hand. Let's just say 8 students raise their hand. Well, the probability that a student prefers tacos in our class is 8 out of 24, okay? But if I wanted to narrow down the focus, and instead of looking at the entire class of 24 students, let's say I wanted to only focus on the females of the class. And I said, okay, out of you females, how many of you prefer tacos? Well, we would get a certain amount of you. Let's say there was 3 of you that preferred tacos as your favorite meal. But notice we wouldn't say that it would be 3 out of 24 because we were no longer asking the entire class. We were only focusing our attention on one subgroup of people. And so it would be 3 out of however many females there are in the class, not 3 out of the total class population. And so conditional probability narrows our focus down to a smaller subgroup of people or things, okay? So it's no different than determining a single event probability. It's actually just as easy, but instead of looking at the whole group, we're only looking at a smaller sample space, okay? So we write it like this, and I think this kind of helps us in understanding what's going on. This is conditional probability. This says the probability of event A occurring given event B. In other words, we are not considering the entirety of like a Venn diagram. We are only focusing on the group of B, and we're looking within that group of B how many A's there are. So not how many A's are in the entire thing, but how many A's are in just the group of B. Okay, so we'd say it like this. The probability that event A occurs given that event B takes place, I guess you could say first. Okay, so the event space is actually the intersection of A and B, because I don't want all of A, I only want the part of A that's inside of B. So if you consider a Venn diagram, the part of A that's inside of B is just the intersection of the two. And the sample space is not the entirety of the Venn diagram. The sample space is only event B. And so, let me take a step back there. So, hopefully you understand that concept. And you can think of this as kind of a fraction, A over B, but it's not all of A, it's only the A that's inside of B, so A over B. The denominator is the B value, right, is B, and then the numerator is the A that is inside of the B, or the intersection of the two. Let's take a look at an example of what this looks like. And we actually have a lot of examples today, so hopefully if you had any questions or any concerns, this clarifies some of that stuff. There are 90 cranes that belong to the Cocoa Wildlife Conservation Trust. The cranes have been categorized by gender and type as shown in the two-way frequency table. So we have gray-crowned cranes, white nape cranes, and Stanley cranes, and then we have male and female cranes broken up like that. Now, I've only filled in a certain part of the table because I've given you enough information to fill out the rest of the table. So go ahead and try and fill out the rest. Pause the video and then come back and check your answers. So we can fill out the rest of the table. The total gray-crowned cranes is going to be 29, right? And then because the total is 90 out of everything, and I know that there's 29 gray crane cranes and 31 white nape cranes, I can add those up and subtract that from 90 to figure out that there's 30 Stanley cranes. From there, because I've got 46 females and 90 total, that means there's going to be 44 males, right? And then because there's 30 total Stanley cranes and 11 males, that means there's going to be 19 females. And then 14 just filling in the rest of the table by addition and subtraction. Okay, and so that's our table altogether. We can't really do a Venn diagram on this. I mean, we could, but it would get kind of gross because we're not comparing two things. We're comparing three. We've got 3 different types of cranes, and then male and female. So we can't. A Venn diagram wouldn't be beneficial in this case. But let's go ahead and take a look at some example probabilities here. If a female is selected at random, what is the probability that it is a Stanley crane? Now notice, it doesn't say if a crane is selected at random. We're not looking at everybody now. We're only looking at the subgroup of female cranes. And so this becomes our new sample space. And so we'd write it like this. We'd say, what's the probability of a Stanley crane given that it is female? So we are selecting out of the group of females. We're trying to figure out how many are Stanley. So remember, it's the probability of S given F. That's how we read that. And that's equivalent to the probability of S intersect F over the probability, or sorry, it's equal to S intersect F over F. So our sample space is only female. So how many females do we have? We have 46 females. That is our sample space. Now, out of the 46, we would say how many Stanley cranes are there? There are 19 Stanley cranes out of the 46. We're not going to put 30 out of 46 because that would include the 11 that are not female. This is conditional probability. How many are Stanley out of the female? There are 19 Stanleys of the 46 females, which is 41.3%. For B, it says, what is the probability of M given W? Well, what does that mean? Remember, that line means given that. That means we are looking for the number of males out of the white-naped. So our sample space is going to be the white-naped. Well, how many white-naped do I have? I have a total of 31. So that is my sample space. That's going to go in the bottom. And then what's my event space? My event space is the males that are inside the white-naped. I don't want the total males. I just want the males inside the white-naped. So it would be 17 out of 31, which works out to 54.8%. I do want to point this out, that if you took the total males and put that over white-naped, that wouldn't make any sense. 44 out of 31 would be more than 100%, so you know you did something wrong there. But remember, conditional probability is we are focusing our attention to a certain subgroup, and that subgroup is this thing here, given that it's white-naped. And then we are looking for our event space to be inside of the white-naped. Okay? So here's another example. I want you guys to pause it and come up with all these probabilities on your own, fill out the table, and then come back and watch the video to make sure you understand this. For this, we are talking about the Wildlife Trust also has flamingos, and they're categorized as Chilean and greater, and we broke them up by gender as well. Filling out this table, I'm not going to go over that. Hopefully you got all those values for the table. And then for 2, it says explain what each of the following means and determine the probability. Well, in option 1 or question 1, it says what's the probability that a flamingo is male? So notice there's no conditional here. There's no condition. There's no requirement. It's just what's the probability that the flamingo is male? So that would be the total males, 33, out of the total flamingos, 33 out of 60. Again, our sample space is everything. The only time our sample space gets smaller is if we have conditional probability. And so that works out to 55%. Question number 2 says, what is the probability that a flamingo is male given that it is Chilean? So this is conditional probability. That means our sample space is getting smaller. Well, our sample space is the Chilean flamingos. So that means we are only looking at the 29 Chilean flamingos. And out of the 29 flamingos, how many of them are male? Well, 16 are male out of the Chilean. So 16 out of 29, which is 55.2%. For number 3, it says, what is the probability that a flamingo is Chilean given that it's male? Now, because they have the same letters, some students might think that it's the same answer, but it's not. We are looking at our sample space of now males. We're focusing in on just the males. So our sample space is 33. How many of those 33 are Chilean? Well, that would be 16. So 16 out of 33 now. Notice the event space was the same, but the sample space was different. So you end up with 48.5%. Now this one gets a little bit more complicated because we have a not in it. What is the probability that a flamingo is male given that it's not Chilean? Well, in this table it's pretty easy because if it's not Chilean, then it's greater. But if we had more options like in the previous problem, you would have to add up all the other things that are not Chilean. So how many things are not Chilean? Well, there are 29 Chilean and 60 total, so there are 31 that are not Chilean, and that would be the greater in this case. And then how many of those 31 are male? That'd be 17. Another way to write this in this basic case, because it's only comparing two things, is what's the probability of male given greater? Okay, and then that probability would be 54.8%. Number 5, what is the probability that it's not male given that it's Chilean? So our sample space is going to be Chilean, which is 29. Our event space is all the not males. So the not males are the females, which is 13. And that will simplify to 44.8%. For number 6, 7, and 8, these are not conditional probabilities. There's no line here, there's no given that. Therefore, we're looking at the entirety of the group of flamingos, not just a subgroup. So what is the probability of a flamingo being male and Chilean? Remember, our sample space is going to be the total. Male and Chilean implies one thing, male and Chilean. So it'd be 16 out of 60, which simplifies to 26.7%. Number 7, what's the probability of Chilean or male? Chilean or male? Well, again, the sample space is 60 because it's the total. Is this Chilean or male? Yes, it is, because it's both. Is this Chilean or male? Yes, it is. It's Chilean. Is this Chilean or male? Yes, it is. It's male. Is this Chilean or male? No, it's not. It's neither. So our event space would be 16 plus 13 plus 17, which is 46. Another way to approach that is you could have added the 16 and the 13 to get 29. So added the 29, added the 33. But remember, when you add the total Chilean and the total male, you're actually adding their intersection twice. So you would say 29 plus 33 and then minus 16. And you still would have gotten 46. And that probability is 76.7%. All right, last problem on this page. What is the probability of a flamingo not being male and being Chilean? Notice there's no complement on the C, so we want the Chilean and we don't want the male. How did I change colors there? That was kind of cool. Okay. Nice. I didn't know I could do that. All right, so the probability that not male and is Chilean. So because it's an and, it's going to be one thing. Well, the not male would be these ones, and then and Chilean. So it's going to be 13 out of 60, and that is 21.7%. Okay, last problem here. I want you to try this on your own and then come back and see how you did. 80 random students were asked their grade level and whether they had more or less than $5 in their pocket. The results are shown in the table below. And so you can see we've got 9th graders, 10th, 11th, 12th graders, and how many have less than $5, how many have more than $5. So we can fill out this table. Oh, I didn't give you any questions for you to answer. So let me, it says draw a Venn diagram where one event is the students who are upperclassmen and the other event who are students who have more than $5. So we want to draw a Venn diagram that only focuses on upperclassmen, that means 11th and 12th graders, and focuses on students that have more than $5, so only focuses on this row here. So go ahead now and pause the video and answer these questions and then come back and see how you did. Before we get into the Venn diagram, we got to fill out this table, so we're going to go ahead and add all those up. And so we end up with 21 freshmen, 19 sophomores, 26 juniors, and 14 seniors. And then we could add those totals up to get the grand total of students that were asked, and that should add up to 80 because it says 80 students were randomly selected. Now when we're doing our Venn diagram, we would have one circle that says upperclassmen, so like you, and another circle that represents like F for $5 or more. So in the upperclassmen circle, you would have at the bottom of the line, you would have 40, and then inside you would have 28 that have $5 or more, so that would be the intersection of the two, that'd be the football. and then you would have 12 that are the moon of the upperclassmen. So that's the outside. So the 12 plus the 28 should add up to the total of upperclassmen. And then in the other circle, those are the students that have more than $5. So the total number of students that have more than $5 would be all of these. So that would be what, 17, 34, 40, 45 students have more than $5. So that'd be at the bottom of the line. And then again, 28 are inside the football, and there's going to be 17 that are in the moon shape because they have more than $5, but they are not upperclassmen. And then the leftovers are going to be all the lowerclassmen that have less than $5, so that'd be 23 on the outside. Figuring out these probabilities, we actually don't need a Venn diagram to figure out these probabilities. Part B says, what's the probability of having $5 or more given that you're a 9th grader? Well, if you're a 9th grader, that is your condition, so that is your sample space. So it's going to be over 21, okay? Oops, I guess I didn't walk through these. So our sample space is 21, and we are looking for the group that has more than $5 out of the 21. So it would be 8 out of 21, and that works out to 38%. For C, what's the probability of having more than $5 given that you're a 10th grader? That means our sample space is 19, and our event space is the 9 inside of the 19. So it'd be 9 out of 19, which is 47%. And then D, what's the probability of having more than $5 given that you're 11th grader? So our sample space is 26, and our event space would be the 17 inside the 26. So 17 out of 26, which is 65%. And then E, it says, what is the probability of having more than $5 or more given you're a 12th grader? So that'd be 14 students would be our sample space, and 11 students would be our event space. So 11 out of 14, which is 79%. And in the last question here, it says, what do the results of the probability imply? And so this is kind of where probability goes. This is what statistics does for us. It helps us understand the likelihood of certain events happening more often than other events. Well, what do we notice? We notice that our upperclassmen have a higher probability that they will have $5 or more than the lower classmen. So we would say that the upperclassmen generally have $5 or more, where the lowerclassmen don't necessarily. All right, that wraps up this lesson. This is, like I said, the last lecture for this unit. So go ahead and do the practice problems below. Make sure you're checking in with me if you have any questions, and I will talk to you later.